Hello, our final project is about the recommender systems. The background, here is the background info. The user preference prediction has been studied intensely both in industry and academia recently. In order to improve the accuracy of the prediction, we have to consider the trade-off between model efficiency and the effectiveness for large-scale recommender systems, even the time limit of responding. For millions or even tens of millions of items among the corpus, this system should recommend K items, under which conditions it is impractical to recommend the top items and predict the preference score of each user item pair. Focusing on this problem, we want to tackle the problems like how to retrieve the top K items for each user and avoid the intensive calculation in the meanwhile. This kind of problem is important and worth studying. The data sets comes from the competition held by Tianci, a Chinese competition platform. Please refer to the website. It was put in the notebook for more details. The training sets contain 3 files in total. They are user behavior files, the user profile, and the item information file.
The first algorithm we tried was DDPG. It stands for Deep Deterministic Policy Gradient, which uses 4 neural networks: a Q network, a deterministic policy network, a target Q network, and a target policy network. The Q network and policy network is a simple A2C algorithm, but in DDPG, the actor directly maps states to actions. The target networks are time-delayed copies of their original networks that slowly track the learned networks. To prepare the setting, we download the dataset online and unzip the dataset and prepare it by the prepared dataset Python script. It shuffles the dataset and along with other settings. And we pre-train the embeddings by learning rate of 0.01 and 4 epochs. And finally, we train the model by using the original setting as the baseline. We use batch size as 2048 and the number of epochs as 20. The learning rate was 1e to the minus 5. And we also tried other hyperparameters as well. For example, we tried learning rate as 1e to the minus 4 and hidden size as 128 and gamma as 0.8.
The second algorithm we tried is BCQ, batch constrained deep Q learning. And this is a quite new algorithm in this area, developed by Fujimoto, and it's an off policy deep reinforcement learning. So the advantage here is off policy. So it resolved the extrapolation error by DQN or DDPG. And so here we trained this model also in a similar setting of DDPG with the variance in a different learning rate, hidden size, and gamma. So after training these 2 models, it comes to the evaluation stage. Here, during evaluation, we have 2 metrics. First is the rewards. So it's just the intersections of top 10 predictions and the true labels. Another one is NDCG, normalized discounted cumulative gain. So gain is the relevance score for each item recommended. And NDCG is actually a very good balance of the relevance score and also the precision of this model. So next, Wentao. You are muted.
So as Xinbang mentioned, we have different hyperparameters to test the best performance models. And here's a chart, different chart for the different evaluation matrix. So for example, like this is a reward evaluation matrix. We have different parameters. This is the baseline, also different learning rate and different hidden unit and the gamma values. And the solid line indicates the training data, how it changed over the epochs. And the dashed line is the validation data. And as a final result, we find both two algorithms are converging, and the DDPG has a faster speed. However, since due to the limitation of computing source, we have not yet to see the final performance. So we will do the more training in the future. So thanks for watching.